is this fair? Some of the ones that have easier derivatives, the process is not bad. When the derivatives get messy, those ones are hard. That's about where you should be. That's okay. All right. My computer crashed. Oh, the net crashed. You know how like these laptops die at a minute's notice? Actually, with no notice, to be honest. I was working yesterday in a meeting. It's a sad day. I lost all my tabs. Okay. I know. I thought of you guys. So I also, less importantly, I lost the completed notes that we had gone through. So you guys were to watch the video, pause, and try the problems as we went. Did you do that? Gavin? Did you do it? All right. So right now, we're going to take a couple minutes, and we're going to go over any of the example problems that were confusing, any of the homework problems that were confusing, and just clear up some stuff. All right. Now, understand, it needs to be one of those problems that's like, hey, I really didn't know what was going on. I had no clue where to go from here, because you could probably see why one or two of these, me going over them, will take up the whole class. Okay. So which ones would you guys like to discuss? Dom?
Number 25.
Yeah, could you tell me which one that one was?
F of x is equal to 1 over...
That was the 1 over the square root one?
Yeah, 1 over the square root of 1 minus x squared.
Yeah. Okay. What's the and if you're wrong, it's okay. Because I haven't been really clear about this. Before even step 1, what's the first thing you should consider with the problem? Domain. Thank you. Domain. And if you haven't been doing it, here's what I will say. If you don't consider the domain first, you're probably still going to get it right, but there may be a little bit more pain along the way. All right? Because what you're going to do is you're going to find out later on, oh, the derivative didn't exist here. The derivative didn't exist here. Why not? And then, oh, yeah, I should have checked the domain. Can I give you a quick example? Is that okay now? We veer off a little bit. What if we take a look at the simple graph y equals radical x? You know what that graph looks like, don't you? Like that? Ish? Do we all know that? All right. What's going on at 0, 0? If I were to say classify any max, mins as local or absolute, we would say 0, 0 is an absolute min. Where would that come from in our process, our 6-step process? 0, 0. Would it come from the derivative equaling 0? So it would not come from step 2. It would not come from a critical point of step 2. Do you agree? What about step 3? The derivative doesn't exist. We think no. We'll hold on, put a little pin in that. Endpoint. Endpoint? Okay. We'll think about it. Step 1. F prime of x. 1 over 2 radical x. Everybody agree? Cut to the chase. 1 over 2 radical x. Yes? Step 2. Does the numerator ever equal 0? No. No critical points from step 2. No smooth critical points. Step 3. When does f prime of x fail to exist? Well, here's f prime. When does it fail to exist? When the denominator is 0. When x is 0. Do you agree? So that would actually come up from step 3. Oh, wait. I thought that was an endpoint. Both. All right. It's both. It's a natural endpoint. So endpoint / critical point. Why? Because the domain of this thing, the domain is 0 to infinity. 0 to infinity. What's the domain of the derivative? Zero to infinity with a parenthesis. Do you agree? Why isn't f of x differentiable at 0? Is it continuous at 0? Endpoint, this goes way back. Endpoint continuity. Well, it's continuous. The limit exists from one side. Okay, got it. Continuous at 0? Yeah, it's filled in. It's an endpoint. Is it differentiable at 0? No. Why not? Okay. Vertical tangent? And that's kind of a weird one because it's like, how could it have a vertical tangent if it didn't exist to the left? But is it vertical at that point? Is it infinite? Is the slope infinity at 0? 1 over 0? Yeah, I would get on board with that. Yeah. Another reason for the derivative doesn't exist at 0 is that the slope needs to exist from both sides. The slope, the derivative, for the derivative to exist, the slope from the left and the slope from the right need to be equaling the same value. Do you agree? And there's no other side to it. Interesting. So here's what I'm talking about. Did you have to do the domain first? No. But then when you get to this point, when you get to this step and you start to think about, oh geez, I need to test this, and you put 0 on the number line and you go to test before it, you plug -1 in here into step 5 for the number line test. Oh man, it doesn't even exist there. I should go back and look at the domain. You see how it's going to kind of come up, but it might be confusing along the way. All right. That was a little sidetrack. Not that I ever get sidetracked in this class, but you know. Am I your most off-topic teacher? Wow. Okay. That's something I need to work on. Thanksgiving goals. Okay. Come back. That's a good thing?
Yes.
Yeah.
Keeps me interested.
I don't teach that in college. Huh. All right. What's the domain of this? Well, 1 minus x squared needs to be, we'd usually say greater than or equal to 0 for square roots, but it's in the denominator, so just greater than 0, right? When does that occur? How are you guys solving that? Are you graphing it like I recommended to? I'm just warning you right now. These sections will eat you alive if you don't practice them. Okay? If you don't take, and I know things have been kind of chopped up with me being out yesterday, it's even worse for 7th period. They missed the entire Wednesday lesson, the first lesson, because of pictures. All right? They missed all of 7th period. So I'm nervous. But you guys have seen it. We need to at least be on board with I can do that part. If you can't do this, you need to do something to make it for you to be able to do it, whether it's ask questions or get help from someone else. Solving this green problem is solving what for you? The domain. That's it. Solving this little green problem is solving the domain issue. Here we go. Do you know what the graph of 1 minus x squared looks like? If you can graph that and look at where it's positive, you solve the domain. 1 plus x squared? No. Minus x squared. Okay. I want to know where that is greater than 0. Oh, I'm just looking to see where that graph's positive. Beyond its zeros or between its zeros? Between. Including? No. Between. Do you agree? From -1 to 1, non-inclusive, is the domain of this function. Domain. -1 to 1. Non-inclusive. So guess what that just told us about step 4. What's step 4? Endpoints. No endpoints. The graph only exists between -1, but not at -1 and 1. You with me? So any extrema are going to come from interior critical points. We're ready to start the problem. Kind of. I want to rewrite this. I don't want to do the quotient rule. I would do that. I would recommend doing that first. Step 1. On the last chapter test, and yes, I finally got this grade. I think I graded this one. I had to grade both parts, which is like 2 quizzes. Then combine them because they weren't stapled. Add up all the points, stick them together. I'm working on it. I'm working on getting grades in. I hopefully will get all that done today. All right. So one thing though, some people were forgetting the chain rule quite a bit. All right. The times du dx. The times the inside over to the inside. Okay. So be careful as you do this. I would hate for you to miss step 1 and then boom, the rest of the problem is just rough. All right. Step 1, you should write the derivative in its nicest form. X over 1 minus x squared to the 3/2 is what I would consider its nicest form. Step 2 makes x equal 0 a critical point. I am going to go through this quickly because we've done a couple of these. Step 3, when does the derivative fail to exist? Well, we just saved ourselves some headaches, right? When does the derivative fail to exist? Well, here's the derivative. It only has issues when the denominator is 0, and isn't this underneath an even root? It's sometimes hard for students to see, but it's 1 minus x squared to the 1/2 cubed. You have to square root it before you cube it. All right? And you can't square root a negative, so this inside, it can't be 0 and it can't be negative. Okay, well, when does 1 minus x squared, when is it? What's the question?
0.
Equal 0 and less than 0. Negative. So when is 1 minus x squared less than or equal to 0? Do you guys understand why I'm not raising it to the 3/2 power? It's a shortcut. Do you understand why, or do you want me to explain it? Explain it? Should it be this? That's the denominator. I thought you said the denominator can equal 0. Isn't the whole denominator with the 3/2 power? Yeah, but how are you going to solve this? Raise both sides to the... What gets rid of a 3/2 power? Raising it to the 2/3 power, right? Power to a power you multiply. Reciprocals will make the exponent 1. 2/3 power will make this 1. So what happens when I raise the right side to the 2/3 power? Oh, it's just 0. So that's a shortcut. It's just one step less to get there. So if you have a square root or a cube root or a 5/2 root, instead of raising both sides to the 2/5, you're going to get there. Just take the inside and make sure it's positive and not 0. Okay. So this is setting up for when f prime does not exist. I'm not saying I want it to be less than or equal to 0. I'm not saying I want it to be less than or equal to 0. I'm saying when it's less than or equal to 0, there are issues. We're finding the issues. Okay? When is this graph, 1 minus x squared, less than or equal to 0? Between its zeros or beyond its zeros? Oh, well, look. We already graphed it. When does the derivative fail to exist? At the zeros and beyond. Isn't that the complement of the domain we already found? So guess what? I'm not going to worry about it because we've already set ourselves up for success by finding the domain. We found out where it stops. We found out where it exists. So step 3 is are intervals of where the derivative doesn't exist, not sharp points where the derivative didn't exist. Okay? So already considered in the domain. Now, I'll be very specific. It does not exist when x is less than or equal to -1 or x is greater than or equal to +1. That's when the derivative does not exist. F prime of x does not exist on those intervals. Well, I've already accounted for those endpoints. I feel pretty good about that. Step 4. I forget how I worded it this year. I put, when we wrote out the process, I think I put endpoints either given or natural. Natural. Does this one have any natural endpoints? There were none given. Any natural? Kind of, but not really. If it were inclusive on the domain, we'd have those natural endpoints, right? But it was not. Step 5, f prime of x. We're going to test f prime of x, x over 1 minus x squared to the 3 halves. All right, got our number line. We've got x equals -1, which is I'm going to say endpoint, but we could put like an open endpoint. I'm going to put +1. This is just to protect you from trying to plug in values to the right or left of these endpoints. Again, if you accidentally did, you should have a big red flag coming up that says it doesn't exist. All right. How about our only critical point? X equals 0 is a critical point. What kind of critical point was that? Smooth or sharp? Smooth. All right, so let's do maybe -1/2 as a test point, +1/2 as a test point. Again, I'm going to put f of x first, f prime second, because once we get into section 4.3, we're going to have an f double prime row, f double prime, and just so we're not out of order, technically I'm plugging it into f prime, so it might make sense to put that on top, but I know where we're going with this. I want you guys to stack them like this because we got position, we got velocity, we got acceleration all year. It makes sense that if we plug stuff into velocity, f prime, we can tell what f is doing. All right, here we go. -1/2 squared, 1/2, 1 minus 1/2, positive denominator raised to the 3 halves power, positive. But the numerator is negative, and a negative over a positive is a negative derivative. What does that mean about f on that interval? If your derivative is negative, if your velocity is negative, your position is decreasing. +1/2. Well, same, except for now the numerator is positive. So the derivative is positive. And that means f is increasing. Cool.
I think I missed a step. Why is the derivative not negative?
Where?
I think I missed a step in the derivative. Why is it not negative? I got negative x.
I think it should be, honestly. Now that I'm looking at it, I think I made a mistake up here. Nope.
Negative.
This exponent was negative, so -1/2, and then times the derivative of the inside was a -2x. Those negatives canceled. So now we go to test. So right here, Cole, I put a negative in, -1/2. I got a negative numerator, and this denominator is always going to be positive. Oh, we good now?
Yep. Thank you.
All right, we had a value. I don't know what it is. It was an open circle, though, or an asymptote. We'd have to look at it, right? Sorry, there's so much that, like, can we all stop and agree this is a tough problem? Okay, can we agree on that? Bless you. It's very difficult to teach because there's so much that could be confused in this. Like when I told you earlier, you have to know your derivative rules, like chain rule. You cannot miss the chain rule anymore. I mean, it's just going to wreck you if you miss the chain rule on this. You're just going to get completely wrecked on this problem. Second, do you understand domain? Right? I mean, that's way back when, but if you understand domain, it's going to help you with this problem. How do you find domain, right? You got negative exponents. You got all sorts of stuff. You got solving root problems. Now, what did I do here? Does that mean the original function has open circles there? Or is that just to find the domain? Just to find the domain. What if we wanted to ask about what's happening at those like phantom endpoints, right? Like where the graph just stops. Is it an open circle? Or is it an asymptote? Or is it like some sort of just jump? Like, well, back to first week of the school year. Ready? Here's the function. What happens at -1? What's -1 squared? 1. What's 1 minus 1?
0.
Square root of 0? 1 over 0. Open circle? Removable discontinuity? Or vertical asymptote? Vertical asymptote. Right? Man, it all connects. Okay, so you have a vertical asymptote. So at -1, ready? Here's -1. The graph's either doing this or this. Which one is it? And why? Why? Cole.
It opens upward at the asymptotes because we found the critical point was next to the minimum.
We know this is a minimum. Is it an absolute minimum?
It is a local.
Local? Let's think about it. Ready? We just said there's an asymptote over here. Who votes that? Ready? From the left, f of x is going up towards the asymptote. Who votes up towards? Who votes it's going down towards the asymptote? Who doesn't know? Thank you for being honest. Careful. Decreasing which way? From the asymptote, it's from left to right, it's decreasing. So the function must be going, like, if I'm looking from right to left towards the asymptote, remember how we did the limit from the right? The limit from the right is, okay,
Are you able to skip this out, like, roughly?
we're going to. I will, I promise. But, and that's a great point. This is the biggest struggle. It's like, just graph it and look at it. Like, you idiot, right? Mr. Westphal, why are you doing this? We have a graphing calculator. Just plug it in. This is stupid. Is that what you said yesterday? No? Were you thinking it?
Yeah.
We were all thinking it. Come on.
A little bit.
I'm not stupid. But,
Okay.
what's that, Don?
I graphed with my calculator, stupid, stay charged.
Thank you.
Like,
Had some pent up feelings about that. Ooh, we're almost through a problem halfway through class. Okay. Kylie, you bring up a great point. Yes, but here's the biggest, what's the biggest lesson from this section? It's using the derivative to identify the function behavior, right? Not looking at a graph, using the derivative. I know it's frustrating, but we have been building up all these derivative rules for then application. All right, and trust me, there's a lot of places this can go. This is the type of analysis we have to do to get there. So if we short circuit it by just going to the calculator, we've lost some of the analysis, which is painful. I agree, it's painful. This is not a blast to teach. All right. Well, what happens here? We go from some natural stop in the graph. We're going down. We're going down. Do you all agree? That means the function must be going up towards an asymptote. Okay. I don't know how it's curving, probably like that, but we don't know that yet. That's 4-3. It's going down. Then it comes to a point where x is 0. And then it starts going up. That makes 0 a min. I do not want to count points off on this for justification. You guys have to master this. If you want full points and I ask you to justify the extreme values, here's what you need to do. 2 acceptable answers. There is a minimum when x equals 0 because f prime changes sign from negative to positive at that point. There's a minimum at x equals 0 because f prime changes sign from negative to positive. Option 2. There is a minimum at x equals 0 because f changes from decreasing to increasing. Do not blend those together. It will be wrong. I have students say because f prime changes from decreasing to increasing. That's not right. Your slopes aren't changing from decreasing to increasing. F is changing from decreasing to increasing. Okay? Step 6. Label. 0, comma, plug it into the original. Ready? 1 over the square root of 1. 1. 0, 1. Absolute min. I actually charged my calculator last night, so I'll open it up. By the transitive property, my calculator is charged. Charge my laptop. Laptop runs the calculator. Calculator is charged. Are you criticizing me? And you got coach's award? I don't know if you're that coachable. You're kind of critical right now. Not teachable. Can't say anything about teachable. Congratulations, by the way. Yeah, nice work. And then we got some honorable mentions and second teams, and that's 7th period mostly. Burkett, you got second team, honorable mention. Nice work. Nice work. What else am I missing? Any other soccer players in here? Girls soccer. I didn't see the. Did you guys get all county awards yet?
Yeah,
How'd it go?
post them on our Instagram page, I think.
See, I'm not. I need to follow. Is it what's it on Instagram?
Streaks Bleed Blue.
Say it again.
Streaks Bleed Blue.
I just got an Instagram, so I'm still learning how to use it.
Maybe posts.
A couple
Christmas cards gonna be out on Instagram.
Christmas cards.
Family photos.
Is that what they do?
I don't know. Is that what you're gonna do?
I don't know.
I'll look forward to it.
Help me out. Original. 1 over the square root of. Was it 1 minus x squared? Who's calling me? Ooh, look at that. Beauty. It's a beauty. What do you guys think?
It's crazy.
Is it what we thought it was? Isn't that what we thought it was going to be? Yeah. It's, look, left to right. It's f of x is decreasing and then reaches its absolute minimum and then goes up. Dom, how do you feel about that? Good. Questions? Madison.
Can you go over how you found the critical point in part 2?
Absolutely. Good question. So step 2, the critical points come from where the derivative equals 0. F prime of x equals 0. Well, here's f prime of x. The only time a fraction can equal 0 is when its numerator equals 0. So I set x equal to 0. If it were 5x minus 3, I would set 5x minus 3 equals 0. I get 3/5. That's my critical point. Basically.
Just the numerator.
Just the numerator. The only time a fraction can equal 0. is where the numerator equals 0. That's why I warned you guys a while back. I said write your derivatives as one fraction with positive exponents. This is why. Questions? Kylie, how do you feel about that? Are you happy with the graph? Were you expecting more?
I mean, a little.
Kid?
Okay, so like basically step 2 is just looking when the numerator equals 0, and then the third step is just looking when the denominator equals 0.
If it's a fraction, yeah.
Okay.
Yeah. Denominator equals 0 or some sort of like failing to exist. The reason I say that is because what if it's not a square root? Like what if it's like an ln function? Like when does
I would give up, so.
What if it's not?
we'll talk about resiliency next week. Life lessons. Life lessons to the first derivative test.
Hold on.
One problem down. Others.
What do you do for
Do you have
step
enough time
3?
for
It's not
The question was, what do you do for step 3? This is your joke right now. I'm just kidding. That was mean. I'm just kidding.
Wow.
Hey, listen, you guys are coming at me with like, I'm giving up, this is stupid. This is my livelihood. This is my job. We're going to talk about resiliency, life lessons before Christmas break.
Yeah.
We need it. This class needs it. A little pep talk. A little future planning. College lessons. What to take away from your classes in high school? Wendy, are you hesitant to this?
No.
Why?
Fun.
Not even complimented your hair. Tyler, your hair looks nice too.
Thank you.
Flowing.
Thanks for help us with our taxes.
Oh, yeah.
Working on some taxes. Got all your expenses listed out? Got a spreadsheet? TurboTax, do you need? You have QuickBooks?
Father.
Ah. All right. In all seriousness, you guys, this class is not always about like getting an answer. Because if I wanted to get that answer, I would have graphed it in 10 seconds. So let me challenge you to this. Don't say this way is so much easier, so that process is stupid. Okay? And I'm talking from experience because I probably would have said the same thing, and I actually did early in class. Okay. If you are only worried about finding a derivative, setting equal to 0, finding where it doesn't exist, all of that, and you want to do it in the shortest way possible, you graph it, you hit enter, you look at it, you say there's the lowest point. All right. Can you at least, even if it's not comfortable, can you accept the fact that that process teaches you to think critically, analyze a function, understand its domain, understand the derivative, understand the behavior of a derivative and how it affects a function, and then analyze all the parts together as a whole? Even if it's very uncomfortable and tedious, can you at least accept that? And could you see anywhere in your own life or future in your career where a process that requires you to do those things would be useful? I see it all the time. I don't care what career you go into. I can tell you a scenario where being able to follow a well thought out process that considers all of the pros and cons, or the trappings, or the be careful here, or watch out here, or this is where this equals this is where this doesn't exist. It considers all the elements that go into the possible solutions, and then analyze all of those together. Okay? It's tedious. It's frustrating. I get it. I understand. Okay? But it's pretty thorough, and it can be challenging, and it can test you. All right? So don't lose sight of that and all of that. Other homework questions? Dare I ask? All right. Well, what about? I went through this one in the notes yesterday in the video, right? Why is this different? Ready? It's not so bad to see it again. I'm not going to do the whole thing. What's the domain? 9 minus x squared needs to be greater than or equal to 0. Do you agree? The inside needs to be greater than 0, but it can be 0. It's in the numerator. When is 9 minus x squared? Hopefully you can graph that. Graphing this is going to give you your domain. When is this greater than or equal to 0? Oh, between -3 and 3. Inclusive. Guess what just happened? -3 and 3 became endpoints. Oh, congratulations. You became an endpoint. You count for something now. Feels good about itself. All right. So now we know where to test. We're testing between -3 and 3. So any critical points that come out of this problem are going to be interior between -3 and 3. Do we feel good about that? That's the kind of approach you need to think through. All right. Do you know what this graph looks like? Do you remember from did I graph it yesterday in the notes? Squared 9 minus x squared. Square root 9 minus x squared. Ooh, top of the circle to you. Do you recognize it? Or was it disguised to you? Top half of a circle? Ooh, wait a minute. A circle. X squared plus y squared equals r squared. That radius is what? X squared plus y squared equals 9, because it's centered at the origin. Y squared equals 9 minus x squared. Square root. Y equals plus or minus the square root of 9 minus x squared. Just kidding, just the top. Beautiful. Amazing.
Because it's the square root of 9 minus x squared.
Yeah.
Could you just make it like 3 minus x?
I even complimented your outfits this week.
Honestly, I just don't understand why. Okay, I understand. Yeah, that's fair. Understood.
It's worth asking. Don't want to do it on a quiz.
Yeah.
It'd be embarrassing. I'd probably counter on and say, ha! Not horizontal asymptote either. All right. Questions. Ooh, what about x squared minus square root of x squared minus 9? Ooh. Now, Kyle, I'm just going to graph this one. But before I hit enter, x squared minus 9. Let's do a quick little analysis. Ready? Domain. Now x squared minus 9 needs to be greater than or equal to 0. -3 and 3. X squared minus 9 greater than or equal to 0. Domain? Right? So this graph's only going to exist beyond. More dance moves to add for the next dance. Split domain. What about what's the shape? She's figuring out some freestyle dances. Any ideas? I don't know. Maybe that. I don't know. You think? Beautiful. Ooh, let's work backwards. You see the graph? What would the first derivative test number line be? Ready? I'd put -3 and 3 on my number line. The derivative, ready? F of x, f prime of x. F prime would get a plus or a minus here. F prime would get a minus because f is decreasing. Oh, man. Ready? What would happen on your number line between here? Does not exist. Would you even put a test point after -3? You might. We'll talk about that in a minute. And then you got 3. And then your number line test, ready? F prime would be what on that interval? Plus, positive. Meaning f is increasing. Okay? Don't worry, I'm not doing it. Okay, let's say you did plug in 0 as a test point. Let's say, oops, I had -3. I had 3. I accidentally plugged in 0. What would happen? First derivative test. 0 over the square root of 0 minus negative square root of -9. Oh, shoot, I did something wrong. You go back, you look at the domain. Oh, yeah, I should have done that. All right? So that's what I was trying to say earlier. Are you going to get it wrong if you don't consider the domain first? Probably not. Hopefully not. But do you see how knowing the domain helps you to then understand what's going on your number line? Awesome. All right. Oh, that's not your homework. We did not get to 4-1 today. This was the goal. Mega lesson. 4-1, day 4, notes. All right, we got page last night of 4-1. Page 194. Can you guys help me out? Between the video, the ones I did in the examples, and the homework, I'm only going to give you a couple, all right? Help me out, though. If I've given it to you, please tell me. Did I give you guys 29 yet? Don't write this down yet. 23 I did. 24 I did. 25. 26?
No.
Okay, 26. 29. Those are tough, okay? Hey, read the sign. The bottom one on the whiteboard. No, the bottom one. Did you guys do 20? Yes. 21? Yes. 22?
Yes.
23?
Yes.
I'd say that's pretty good. Now listen, most of the problems you're going to see, we're like overtraining for. We're overtraining for. All right, a lot of these are going to be easier. I hope you all have a wonderful weekend. That's it.
Good day.
Oh yeah.
What I would say though, there's only 2 homework questions. If you struggled with some of the past homework the last couple nights, go back and try some of those, review them. Monday, fair warning, it might be a double or like a triple homework check. Be ready. I haven't checked homework. So not just 2. Make sure you're ready for more than just this one. Make sure you've been keeping up.